Great. So welcome to this webinar. I make it 3 o'clock, so we'll dive into the new format for us both. So I hope we have a good time together. Just to sort of run through how we're going to play it, we've got 1 hour to chat about perfection. Will it be possible for ASR to do that in subtitling? Yeah, we've got 1 hour. I'm going to respect your time. Hopefully, give you a sharpish finish. To give some context, this sort of follows from a presentation that we both did together at IBC. We're going to hopefully dive into the topics in a bit more depth and open up for answer more questions. Sorry, I've got some feedback here. There we go. Hopefully a bit more conversational style, chance for you guys to dive in with questions as we go along. We'll try and deal with them as they come up. If not, we'll have a look at the end, see if we can answer them for you. So on the agenda today, we're going to have a think about subtitling, vocab size, punctuation, overlapping speech, real-time ASR, speaker identification, segmentation, and then we've got some time bring fans for more questions. It's going to be a double act between us. Hugh's hopes are going to keep this grounded in the real world, stop me from going off into airy-fairy projections about how perfect ASR is going to be or already is. So yeah, with that said, let me just start by a couple of introductions. So Speechmatics, company that I work for, we're a speech recognition provider, a machine learning company. We offer speech recognition in private and public clouds and securely on-prem as well. We're offering I think 75 languages now. So we've got good language coverage, and we sort of aim to be the most accurate and easy to work with provider out there. As for me, my name is Will Williams. I'm one of the first few employees here. I've worked primarily on the machine learning aspects of speech recognition. I'm now also working more on exploratory R&D projects, so very much looking to the future, which sort of I suppose links quite well with the topics today.
Yeah. My name is Houston Maxwell. I'm the head of technology development for Red Bee Media. Red Bee Media is a global broadcast services company working in playout, media management, over-the-top platforms. And my part in particular is part of data services, which is content discovery, and I do access services. So my group works on subtitling, audio description, signing, things like that. I have been responsible over the last year for the incorporation of ASR into a lot of our existing workflows and new products. And as I've been working on that, I've come across with my team a lot of the challenges that we're going to set to you today, things that we see emerging in subtitles and that we'd like to see ASR bring a bit more on. So in Red Bee, we do about 200,000 hours of subtitling a year. And that's when I say subtitles, these are for the deaf and hard of hearing. They are in the same language as the original media, as opposed to say where it's in a different language so that people who speak different languages can understand it. So I'll sometimes call it captioning, which is what they call it in the States, and I'll sometimes call it subtitling because in my head now it's just a mix of the two. And what we're really talking about there is transcription, which is why ASR is the perfect tool for this, and it's increasingly becoming the most fundamental tool for that. People have been coming to us at trade shows for a number of years now saying, I can talk to my phone and it understands me perfectly, so why do I have to pay for subtitles? And of course, the reality is more complicated than that. The expectations that customers have and the regulatory environment means that we're expected in a real-time program to achieve accuracy levels of 98% in an NER score. For offline subtitling, the expectation is basically 100%. Any mistake is seen as unacceptable for offline subtitling because there is the time to give a perfect result, and that is what audiences expect. So what this means for the use of ASR, well, in a real-time case, we can use real-time ASR, but generally we would be using it in areas where there is less expectation or there would be no coverage without it. For offline, it generally means there is a human QC after the fact to take that transcript and improve it. And right now, we see that ASR is worth using for around 30% of the material. That is to say, it is quicker to use ASR as a first pass and then correct it than to do it from scratch. That still leaves about 70% where what we find is it's quicker to do it from scratch, and that's simply because correcting text is actually quite time consuming, whereas generating it is a little less so, depending on how many corrections you have to do, of course. In terms of specific challenges, so the first one we were going to talk about was vocabulary size or new words. So in broadcast, there's all sorts of strange programs we do, which are about really specific topics with vocabulary coming up that would never be in any training data set. And even in things like a news program, every day brings in new vocabulary. Like recently there was Novichok, which is suddenly being talked about a lot on the news, but would never have emerged in most training sets before that. So we need ways of handling that. Traditionally, and this is a very effective technique, we use house styles, where if we see that something is being misrecognized consistently, we can put in a rule to simply substitute it, and that can be based on the particular program, so it only substitutes it in an appropriate time. We've looked at using genre-specific ASR models. That's never really given us great results. We generally find that by constraining the data set, yes, it'll get the specific vocabulary right more often, but it'll get the generic grammar and vocabulary wrong more often, and in the end, you don't really gain anything. And then a last option we have is to use the ability to put vocabulary into the ASR model in real time to tell it to expect these words, and Speechmatics offer this as well. This can work well in certain scenarios, but it can also lead to the ASR being overeager and starting to hear those words all over the place because it doesn't really have a context to know where to expect them. So where do you think improvements are going to come on vocabulary size and these rarer bits of vocabulary?
Yeah, so yeah, first thing to say is that as you're adding more words to the system, you're going to have more confusions that are possible. So it is a much harder task in general, particularly if you're adding lots of really really short words. If you're adding long words, like some long sort of pharmaceutical product, it's probably going to get that perfectly right because it's just easier to be able to track through that word. So if you're adding lots of short words, there are lots more confusions possible. So just in general, it is a harder problem. But in terms of how to handle it, I mean, we're starting to already attack that problem, and you're obviously still having problems, so there's still a way to go. In general, what we have is in speech recognition, you have sort of often a constrained search space of words. So as someone's speaking, you're sort of navigating through this search space, and it's constrained. So it's constrained by your vocab size typically. And what we need to do is say, okay, we've got a new word. We need to insert that into this constraint or this graph that we're searching over. So how do we best do that? So we have at Speechmatics something called sounds, the sounds feature, which means you can give us a new word, tell us what it sounds like, so we can absolutely nail the way that word is going to be pronounced. And that tells us how that word should go into that graph in terms of how the word is decomposed and what it should sound like. Actually, because we know we can model really well the sort of components of that word, the subcomponents, already really well with our acoustic model on other words, we know that part of the problem is probably going to be solved. It's going to be fine. But like you're saying, the grammar aspect of it is certainly a little bit more shaky. So probably got the correct pronunciation for that word, but we might not have the way that word is going to be used in the sentence. So and that's where confusions can start to creep in. So how can we fix that? I'm thinking maybe some of the work to do with subwords. So this is all to do with language modeling, which says if you have a sentence, is that sentence probable under English or is it not probable? And we want to give sentences high scores that are most probable. So how can we boost the scores for these words in the right context at the right time? And maybe it'll help to break that word down into subwords. So imagine the word you added was Novichok. We know how to model ing words pretty well from everything else we know about English and all the data that we have that end in ing words. So if we can say in some way in our system say that word is actually quite similar to all other ing words, then we can know at what position it's likely for that word to appear, and that can help our search, and hopefully the search won't go wrong. So there's some interesting work that can be done on that. The other thing is to do just the tuning of the whole system. So often speech systems won't be set up for you to come along with a cartload of 100, 200,000 new words, shove them into the system, and it perform how you might expect. So there's some, I suppose, tuning to be done that means that when you do turn up with those huge amounts of new words, that you don't bias that search to those new words. And I think, in all honesty, it is a question of tuning to get that right. There's no sort of technical reason why that isn't possible. Just need to make sure we don't degrade performance on stuff that we're already doing. So yeah, I think the future's pretty rosy for this. It's just getting that balance right. Maybe doing some clever work with embedding these words into a useful space that means that we can model the grammar and the language in a nice way.
Okay. So another area where we have a lot of problems with current ASR solutions is punctuation. So punctuation for fully automatic workflows is very important to correctly segment subtitles and for them to be readable. Or for those where we have QC process, it makes it difficult to pre-segment it, and resegmenting it is quite time consuming because you end up having to retime the subtitles, etc. It also is quite time consuming to put punctuation into unpunctuated text. So yeah, I believe you're hard at work at this.
Yeah, so I've been looking at punctuation quite a bit recently. It's quite an interesting topic. I don't know why current systems aren't really doing a good job of it, because I think in terms of machine learning, it's actually quite a reasonably easy task compared to other stuff, particularly speech recognition itself. Yeah, so I mean, compared to yeah, the issue with dealing with new words, I think actually, yeah, it is reasonably straightforward. It's easy for humans to learn a bunch of rules that do punctuation-ish, and so as long as we can have those rules in some data sets, we can learn that mapping from non-punctuated to punctuated. One of the things you've been saying is how it's easy for there to be maybe too much punctuation, and that not actually help with readability. We've been finding that if you go for a focused subset of punctuation, so maybe you're only doing like full stops, commas, and question marks, for example, that sort of focused subset is enough to give you 90% of the sort of gains that you need to improve readability. So I think that's what you're really going for with punctuation on ASR output is that readability.
Absolutely.
You don't want to be introducing EM dashes or quotes or things like that. It can get really messy really quickly. You want to keep it punchy and yeah, and readable. That's the key.
I think the audience is what they mostly care about are full stops, question marks, and commas.
Yeah, well, yeah. So it's interesting how you found that from your side and we found it from our side as well. So yeah, I think the only sort of struggle that we're facing is on the accuracy front is those cases where you kind of really need real world knowledge to disambiguate between putting the comma maybe one place forward or one place back. You know all those sentences where you can completely change the meaning by putting the comma in the wrong place. It's those really hard edge cases that that are still easy to get wrong and hard for machine learning systems to deal with.
I think we could live with the edge cases still being wrong.
Yeah.
And if we're getting the ones where the punctuation is really clear, right, that would be a big productivity boost and a big readability boost.
Yeah, yeah, well indeed. Yeah, so I think things are quite positive on the punctuation front.
I suppose it's interesting as well that it has been, you've described it occasionally as a second-class citizen. I think it shows a lot of ASR is driven with other workflows in mind, not necessarily our particular use case. And, you know, if what you care about is getting at some keywords or, you know, command and control or some other type of ASR endpoint, punctuation doesn't really matter for that, but it does matter for us. So I guess that's why it's been neglected.
Yeah, maybe. Yeah, and it's something I think certainly we should be doing a good job of. It's nothing worse than looking at a whole giant block of text and just being intimidated by it because it just hasn't got those natural breaks which you just assume are in there. So there's no reason why it should be like that.
Good. So another one issue that we've talked about is uncommon dialects. As an Irishman whose phone has only just started understanding him recently, I know that having a less common dialect really affects the performance of ASR speech engines. And what's more, broadcasting has changed over the years. You know, while it used to be on the BBC, all you would hear was RP. These days, broadcasters want to represent the full linguistic diversity of their audience and their wider language group. And that is clearly a great thing from the point of view of producing accurate subtitles with ASR. It's a pain in the backside. So yeah, how can we improve this?
Yeah, so I mean, the first reaction is to say that it's primarily a data issue. So if we did have sort of a representative, I guess, sample of all the speakers that you'd expect to be dealing with on your side in our data sets, then maybe this problem wouldn't be there. The truth is, to get machine learning systems to work, you're often training on like a lot of data, and to get a lot of data, you're not going to get the rare accents in those data sets. So there is a big issue of how we get that data in the first place. Long term, we're ideally going to want to be incorporating more and more different speaker types and different accents. But But I think in the short, well, if you're looking realistically at it, I just don't think those data. I don't think those data sets are you're going to get hold of them unlabeled, and to get them labeled is an even bigger ask. Maybe over time we will, but I think it's very unlikely in the next few years that somehow magically we're going to get really, really good data sets that cover what you're expecting and hoping. So I think at that point then we start to turn and think about some other kind of interesting techniques that might help here. So something in machine learning is domain adversarial adaptation, and that's kind of where you might have lots of unlabeled data in a hard accent to deal with, and you find and you learn a mapping from that data into the space that you model, or the space of speakers that you typically see, so your RP sort of pronunciations. And so then the idea would be from all these different accents, you learn that mapping to this same space, and then you train on that. So so at train time, we're still kind of learning something similar, but we're actually learning how to deal with these other types of speakers at the same time. And yeah, these techniques are starting to be looked at, investigated. People are getting some good results with them. Yeah, I'd like to yeah, see what happens with that.
If you imagine a scenario in which the data is there, where suddenly great quantities of data become available in some range of dialects, is there a limit to how much dialectical, if that's a word, complexity you can model? Like how many dialects can we fit in a modern engine today? I know you guys have done good work in global English and covering, say, US and British English with one engine, but that's mainly the mainstream dialects of those regions. Yeah. How much can we fit into an engine with the current state of the art?
Yeah, so I think I'm kind of forced to pluck numbers out there a little bit here. We know it's possible for two, so we did like I said, we jammed US English and British English into one model. That seemed to work well. It seemed to also start generalizing to other accents a bit better as well. So there are some nice kind of like almost like network effects in doing that. Kind of you've done it for a couple of accents, and then suddenly you start learning the patterns that generalize well to other accents as well. I suspect maybe 3, 4, maybe 5 you could do a really, really good job of, and then maybe see some generalization benefits across to other accents as well. But that's a real pattern that we're seeing, is that it's possible to do this, and it's beneficial from like a almost operational sort of complexity point of view. If you can put all your effort into one model, it's doing well on the stuff that you train it on. You're training it on more and more different types of speakers and dialects as time goes on. You're doing a really good job of that all in one model, and then it's starting to generalize to other things that you'd never started to see before. That's really where we want to get to.
You guys have used some sort of generalization from other languages when you've been building up models for languages with less data, right? Is there sort of similar effect to that, or is there a similar approach to take?
I don't, not necessarily. So with a lot of that work, it's saying actually sort of the very small or low-level parts of speech that you might want to model are actually quite similar across languages. So if we trained an amazing English model that's already modeled that stuff, we can just keep those representations and start from them, and then train on other data for whatever the other language is. That works well. I think this would be saying you sort of have a data set that has a good variety of speakers in it, and then it starts to generalize to other types of speakers. So it's more of a kind of, I guess, a generalization question rather than a training efficiency kind of question, which is, I think, what you're referring to.
Okay.
Yeah.
So excitingly, we are now on to topics that we did not cover at IBC.
Excellent.
So new ground. So actually, someone asked us recently, what is the #1 thing that could be improved and that would have a knock-on effect for us? And it probably is background noise, the quality of recording. We have a lot of broadcasts where they're filmed on location, so there's a ton of background noise, or even things that are recorded in the studio and at some point had a perfect quality recording of the voice. By the time we get them, they've had the music added, they've had the explosions or whatever else added to the background noise. So it is generally rare for us outside of things like news to get nice clean audio, single speaker. There tends to be some sort of acoustic distortion or competition with other sounds going on. So what is the way we're going to see improvements there?
Yeah, so this is, I think particularly relevant for speech recognition, because I think it's people's experience that it falls to pieces when, I don't know, you get a door slamming in the background, or you're doing it on the motorway when it's very noisy. Suddenly, things stop working, and It's very frustrating. So I think this is like, we really need to nail this, and lots of speech engines do start to fall to pieces when there's lots of noise. I think the key, at least in the short term, to deal with this is data augmentation. So that's saying take exactly the same data that you've got to train on. So sort of the WAV files of people speaking and the transcripts that go with them, and then you would perturb in some way that WAV file, and maybe you'd add on top loads of noise. And the key would be to add exactly the same kind of noise to that data that you would be seeing when you're effectively testing that system, and making sure that distribution is kind of like representative of what you're seeing. Like we could start adding noise over the top. We could add like I don't know, doors slamming in the background all the time, but if that's not what you're seeing, it's not going to help. So the idea is we want a really sort of representative set of noise that we can start adding onto our training data. We want to add that with like different volume, different speeds, augment it in as many ways as we can to try and make it as robust as possible to what we might see at test time. And I think on the whole, we need to be more aggressive with that data augmentation, so that it really can be robust to whatever anyone throws at it.
Is there a trade-off here where you're thinking again of different use cases? And so in the broadcast world, although again, not always in a news show, this may not be relevant, but a lot of our material has this sort of noisy environment acoustically. Is training your engines to do better on that, is it going to have an impact on how it performs on the stuff that's recorded in a clearer environment?
Most likely. But I guess the counterpoint to that is as models get bigger, they can start to cater for more, I guess, use cases, like that. So, you know, we want to make sure we're not degrading performance on like our bread and butter, clear speaking, clean acoustic environment. I don't think we can afford to let performance degrade there, but we want to make sure that we're doing much better on these really difficult pieces of audio, and we'd never do it to the degradation of like the whole system. But I think you can start to capture more and more of these different sort of patterns and varieties in the data as your models get bigger. You have scope to start doing that. So yeah, I mean, we have checks and balances in place to make sure that degradation isn't going to happen, but it could happen. Like if you did train on, I suppose, just stuff that you had in the studio or whatever, that would skew our models to only work for that use case. So I think that's why this whole big data thing is a real thing. You really need that diversity of data to be able to create a system that's robust and generalized as well.
Yeah. We've at times looked at doing some sort of audio pre-processing in order to clean up or take away frequencies that are, you know, less common in human speech and things like that. And generally we've found it has at best had no impact, and at worst has actually degraded the performance. Is that what you would expect?
It kind of marries with what I've experienced as well. We were saying before, there's possibility that there are times when that could actually work and be helpful. If you knew exactly the kinds of things that we were feeding into our models at train time, and you could somehow map your domain into that, and you could learn some complicated function that could do that for you, then maybe, but I suppose you don't know exactly what that distribution is that you need to map into. It's quite hard. And maybe you don't know which bits of the audio are causing the problem, so you don't know whether to remove, I don't know, all the background noise, or maybe, you don't really know what you have to do with that audio.
I've always assumed that, I mean, particularly if you're just talking about boosting or cutting certain frequencies, one of the first things any model is going to learn is to ignore frequencies that are outside human speech, so that you're not going to really gain anything. Although is that what happens? Is that how it works?
Yeah, I mean, it will be just attending to those kinds of frequencies, most likely. So yeah, and I think it is a complicated function that you'd have to learn. And ideally, we don't want to go down the route where people have to write complicated pre-processing steps to make systems work. They should just work. So yeah, we need to get our heads together to think how can you train this to be a more robust sort of model in the first place. Because I think that engineering effort would then be potentially thrown away as soon as you release a new model, and that's kind of the complexity. You don't want to go down that rabbit hole of introducing that kind of complexity, I'd say.
Yeah. So in a similar vein, another issue we have a lot is with overlapping speech. I mean, an extreme example is a comedy talk show or a political show where everyone shouts over each other, but actually people generally speak over each other a lot in real speech, and in media probably more than you realize, because humans are very good at parsing when two humans are speaking, or when there's a bit of overlap at the the start and the end of a phrase, and that's really hard for any ASR engine to deal with, even though for a human it's quite easy. And for a subtitler, like a skilled subtitler, subtitling something in real time, this is their bread and butter. But for ASR engines, they really tend to fall apart. So this is a tough one, I think. How are we going to get any improvement there?
Yeah, it is a really tough one. I think, the short answer is that humans are doing it a very different way to the speech rec systems that we have. And the ASR systems just simply are not set up to deal with this problem typically at all. So they're not trained on it. And so it's kind of garbage in, garbage out situation, unfortunately. Part of the problem, I think, is in the data. We just don't have necessarily the data that's dealt with the overlaps in a good way. And it's often a kind of quite simple mapping that you're learning in speech recognition. You just have acoustics, you're learning to map to the correct word. So it does introduce an extra complexity if you have overlaps. I know certain groups are looking at how to separate out the sort of sources in an intelligent way beforehand, and then feeding into the speech rec system. I think that's clever. Some people are seeing some progress there. So I think there are steps being made to actually solving this problem, but it is very hard, and I think it's not near the top of people's priority list. I think like getting the accuracy higher is still the priority at the moment. Because it's a difficult edge case to deal with.
Yeah, I mean, it sort of feels almost so much an edge case that you don't really want it in your main engine.
Yeah, definitely. In the ideal case, you could have the correct data. You could construct a loss function that takes all of this problem into account, and you just you learn the model, and it can start to deal with it. But yeah, it's complicating an already complicated problem. Which I'm sure we'll get to it at some point, but I'm sort of less optimistic about being able to deal with overlapping speech.
So we had a question come in ahead.
I was wondering if you have, just before we got any questions that have come in whilst we've been talking? No. Okay.
One of the questions that came in ahead of time was, what is the latency and accuracy with real-time transcription and captioning? Well, from our experience, and we do a lot of assessment on this, the latency is a trade-off. Generally, it is configurable, and you can give more or less look ahead of it. You're effectively holding back to see what's going to come in the next few phrases or next few seconds, and that will push up accuracy, but it'll increase delay. On the subtitling side, we can do things occasionally, depending on the use case, to take advantage of a bit of delay. So if it's being broadcast on HD, we can take advantage of the encoding delay, the time it takes to encode that video, and insert the subtitles later, so you gain back that bit of time to gain a bit of accuracy. Likewise, you can do that with web streaming quite easily. So yeah, if you can somehow insert the subtitles a little later, that can gain you that time. But if you don't have that option, you've got to make a choice about whether you want timeliness or greater accuracy. We also had a question about how good is real-time compared to current TV.
Oh, so we had one which was, sorry, just looking at one coming in here. How's the ASR's development for foreign languages like Portuguese?
Should we come to that after we finish on real-time?
Yeah, let's deal with that later. Yeah, brilliant.
Cool. Yeah, so how good is real-time compared to current captions? Well, on the NER score for real-time, we're seeing in the region of 85 to 95%. And the NER score is this score that is generally used to mark the accuracy of real-time captioning. It's quite time-consuming to do, but it does give a good metric a reliable metric for what is better and what is worse in captioning and what is customer expectation. For captions produced through respeaking or through stenography, generally you're looking at 98 to 99%. So there is a gap even in ideal conditions, although this has improved a lot over recent years, and we expect it to continue to improve. And the threshold is lower than it is for offline. So if you can get to 98%, that's going to start being competitive with human-driven workflows, whereas that's not the case with offline yet. So how are we? Well, I guess there's two things there. There's the latency trade-off, and there's just generally real-time accuracy. Some of the challenges there.
Yeah. So I mean, huge trade-offs here. You really, and the majority of that delay that you have is going to be determined by, in the speech recognition system, when you do this endpointing operation, where you essentially get a pair of scissors out and you say, okay, I'm going to stop here and just have a moment to process and I guess update all the scores and try and output a better output, better quality output. So where the point at which or how frequently you're taking those scissors and chopping is a real I guess decision that we'd ideally want to put in your hands, and you can make that decision, make those trade-offs as best fits your use case. I suppose I was just trying to look forward to the future a bit and think, okay, well, how's this trade-off going to play out in the future? I think we're going to need the language model, or the thing that can sort of fix up sentences based on your knowledge of grammar, less over time. So if your acoustic model, which learns to sort of map the acoustics to the possible words, loosely speaking, as that gets better and better, you're going to need the language model less and less to fix up the confusions. So, and we know that it's super fast already just with the acoustic model. The slow bit is taking this endpointing and running over it with the language model. So I think in the future, actually, things are potentially going to speed up because we're going to need the language model less to sort of do some of this heavy lifting in between your sort of chopping operations. But then again,
if it's possible to see it, what is the kind of weighting given to acoustic versus language model at the moment? And what is the relative rates of improvement in each of those bits?
Yeah, I don't have the numbers to hand. It's a parameter in our system that we'll tune based on some held up data. Typically, I think we're something that we're sort of always looking at. I'm not sure the exact number offhand, but from what I understand, the language model's weighting is getting less and less over time as the acoustic models improve. Sorry if I didn't quite answer your question.
No, it's interesting. I mean, yeah, I've kind of thought more in terms of language models improving in recent years, but I suppose maybe I haven't seen quite so much that the acoustic models have been improving yet. Sounds quite optimistic for real time if that's the way it's going.
Yeah, definitely. And I think they've been improving in the ways that we've kind of been chatting about already, which is that they're handling more and more awkward audio and hard and noisy audio. I think that's where the gains have really come from. Like, I think we were saying this last time, from like the 80s, or even with like a simple sort of system that's trained on just one speaker, the acoustic model can handle it. It can get it right pretty much all the time. But it's this question of how much can it generalize? How much can you deal with really awkward and hard stuff? That's where the improvements are going to be coming from. Yeah.
Should we pick up the language point, given that we've had it come up?
Yeah. Let's think about language.
So from a Red V point of view, I mean, we have been limited in the past by languages supported by Dragon Naturally Speaking, which is the application we use for re-speaking. That I think covers about 7 languages in the way we're able to use it. And so we've generally been limited in the markets we can go into like that, whereas with Speechmatics, you've got, I think, 70 or more languages covered, so that opens up a lot of possibilities for us. For now, personally, our focus has mainly been on our core markets, so we're looking mostly at Spanish, English, Dutch, German, languages like that, but we're very keen to start looking at languages that have had less opportunity to use re-speaking or to have real-time ASR-driven captioning because there just hasn't been the ASR support, so they have to use traditional, people-heavy, cumbersome workflows that produce pretty slow subtitles as well. So, we're really keen to look at that. I mean, in terms of what accuracy is like across the range of languages, I guess that is more of a question for you. So I'll hand over.
Yeah, so I think accuracies aren't as good as our flagship sort of languages like English, but they're still reasonably good, and they're always improving over time. And I hate to sound like a bit of a broken record, but there is a data question there. So like data in Swedish is harder to get. Well, yeah, harder for us to get hold of than English for sure. So so that is really the only reason why there's potentially a little gap in accuracy. So the question came in, how's the ASR's development for foreign languages like Portuguese? Well, the development is just as good as the English is, minus probably the quality of the data. And over time, it's only going to get better. And it could get as good as the English. Theoretically, there's no reason why not. It's just a question of data. So yeah, these languages are always improving. We're sort of rolling out new releases all the time. So it's something to watch, I suppose. I don't actually have numbers to hand, unfortunately. Has Speechmatics done any testing on live content? What was the result?
I don't think Speechmatics will have done any R testing, but we have done any R testing on ASR-driven live content. And as I said before, it's in the region of 80 to 95% on the NER scale, whereas with our re-speaker-driven workflows, we'd expect 98 to 99%. So that's where it is now. I mean, where we're seeing things like 95% in English is where you have a single clear speaker on the news doing scripted content, so it's all clearly enunciated in full sentences, and that the performance can really be, very good. Not quite re-speaker good, but really, useful for accessibility purposes, certainly. Yeah.
Cool. Another question. That's good. Currently, speech-to-text gets expensive at scale. What's the main driver of speech-to-text costs, e.g. compute, R&D, and do you anticipate it coming down in the coming years? Now, this question is probably way above my pay grade, yeah, I mean, I suspect it's similar to other things where it's a bit of a race to the bottom. It's certainly getting cheaper. Yeah, I don't know about us at Speechmatics. I don't know. I'm not privy to these things, but let me have a look. What's the main driver of speech-to-text costs?
I mean, one thing I would say about the idea that speech-to-text is expensive, I mean, if the accuracy was the same, it would be a heck of a lot cheaper than doing it any other way. I mean, I'm not sure expensive is how we would describe speech-to-text, even where it is now in terms of accuracy. There are areas where we are getting efficiency gains, so it is something we spend money on and we see as worth spending money on. So the more accuracy it gets, the more that has value for us. And frankly, the price isn't going up when the accuracy goes up. So it's not something we're complaining about. I mean, obviously we want more accuracy, and we'd welcome if it was cheaper, but it's not expensive. Is not the word I would use.
Okay, cool. Let's press on with a couple of other things that we had prepared to think about.
Sorry, before we do, I just did have one other question on languages.
Yeah.
Is there one modeling approach which is appropriate for all languages, or are there language features that require you to take a different tack? You guys have covered so many languages. I'm just sort of curious, given that languages can vary a lot, especially as you get away from sort of Indo-European languages and whatever. At this stage, are the algorithms used and the approaches used so general that really the actual linguistic features don't matter at all, or do they matter a little, or do they matter a lot?
So the approach that we've taken is to try and come up with an approach that deals with all languages. Everything we do, really, as a company, we're assuming this has to apply for all languages. So like with punctuation, we were thinking about recently, has to apply for all languages. There are certain problems that certain languages have that are like common to lots of languages of that type. So languages with tones or something like this. There might be a slightly bespoke approach for that, but once you solve it for a whole category of problems, and it becomes part of your arsenal. You can roll it out across all languages, so to speak. And we don't want to be taking a custom approach to an individual language. As a machine learning company, we do not want to be writing rules, writing lots of if statements. We really want to put our energy into building really amazing models on data and let the computer sort of deal with that mapping problem, I suppose. So yeah, whenever sort of we take, I guess we want to improve our language coverage. We try and take a a new one of those problems off the shelf that's common to maybe a number of languages that we've never dealt with before, and then we can use that modeling across all languages.
Good.
Should we ever think about speaker identification and segmentation?
Yeah.
We have some questions about that.
So TV regularly comprises of reaction shots, or there's several people in a scene, and it's not easy to tell who is speaking. And more often, again, that I think you kind of notice as a hearing viewer, the person who is speaking is not shown on screen. There is no easy way to identify who is speaking. So one of the things we need to identify in subtitling is who is speaking, and we might do that through speaker marks or through colors or through labels. That sort of segmentation, where we have it, is also extremely useful for dividing up the file automatically. And as I said before, where you have to redivide it and resegment it, that's quite time-consuming work. So this sort of diarization, speaker segmentation, is something that ASR engines often offer, Speechmatics offer. We find Speechmatics implementation is one of the better ones out there. It's still pretty far from correctly identifying who is speaking, or even that someone else has started to speak. Do you think it sits naturally with ASR as a problem? And do you think there are going to be improvements there coming?
I mean, yeah, it does sit naturally with speech recognition. I think it shares a lot of the same problems that you have with ASR itself, like with noise getting in the way. Overlapping speakers is, well, essentially the problem itself. And to be honest, it hasn't really received the kind of love and attention that it needs to be a good product, I suppose. There's a few issues, so there's not a clear metric on how to measure how well you're doing. So there's like diarization error rate, and a number of people have proposed a few other things. It's quite hard to get something that feels right, I'd say. But then if you can solve ASR, I think you can solve the segmentation issue. It's kind of just asking a different question of your data. It's not asking the what question, it's asking the who. Mm-hmm. And I don't see why we can't answer that as correctly as we are the what question. So, and I think we do have the tools at our disposal now to actually attack this problem and deal with it nicely. I think it's just a question of engineering resource and so on. Yeah.
Cool. I mean, it's one we would like to see.
Yeah.
So we had other questions come in ahead of time. Have we any more come in during? Okay, so one of them, which I think blew both of our minds a little bit, was, is there any difference in quality between mono, stereo, or even multi-audio capture? Imagine 20 mics and one mouth. Would that help? Now, from our side, we sometimes see that you get different performance between mono and stereo. Particularly in stereo, less of the noise is contending with the voice if the voice is mixed in the middle, I suppose. But for the ASR point of view, I'll hand over to you.
Yeah, I mean, this is not like the data that we train on at all. So I mean, if you did throw it through, it's probably likely to make it worse. We could probably take advantage of it if we did some clever pre-processing on the front to get the audio into like a really nice space for us to do recognition on. But we almost certainly have no intention to do that. I think the assumption that the audio is like reasonably audible is a fair one to make. And if we weren't making that assumption, we would be putting a lot of engineering effort into something that probably is not going to help most people. Yeah, maybe at some point that kind of thing can help people's output improve, but in the short term, no.
Yeah, I mean, as I mentioned before, in our case, generally for offline, we're always dealing with mixed audio. So even if you've had several mics on set, what we're getting is a mixed down version of that. For real time, it's a little bit different. There are certainly scenarios with it, say an unused program or something, where you might have channeled through to your engine just the mic on the speaker or a couple of mics on the speaker. You might do something like that, and that might improve quality for sure. But that requires a lot of coordination with the broadcaster, which from the point of view of the broadcasters, given that you'd have to coordinate that on every single broadcast, is a lot of overhead.
Yeah. Although it could fix the overlapping speech problem.
Yes.
So you've got multiple mics and multiple people speaking into them. You just run two real-time systems through those two different mics. You solve the overlapping speech problem.
Absolutely.
Completely.
We still need to figure out how to present those two different recognition processes, but
that's your problem, not mine.
Another question we had is it possible to generate custom engines learning from input data and vocabulary continuously like Dragon Naturally Speaking? So this is very much one for you.
Yeah, is it possible? Yes, always possible, technically possible. But maybe it's not the right thing for us to do as a company right now. I don't know. Yeah, it'd always be nice to have a personalized system. I think personalization is a great direction. As a machine learning company, it's a direction that I think, well, as I think in general, the field, machine learning companies are going to go down the route of personalization. I think you'll see Google be doing this more in the future. It's kind of part of their vision. I think it's part of a number of other companies' visions. Personalization, I think, is going to be important. So watch this space. But yeah, short-term wise, it's not something you're going to be able to do probably from Speechmatics. Medium term, who knows? Yeah.
I mean, we use that a lot in Dragon Naturally Speaking for that single speaker, re-speaker approach to producing subtitles that we have in our traditional service, but it's hard to see for the things we use Speechmatics for how it would help or how you would get the best out of it.
I suppose looking over time, you're going to see those two types of systems converge to the same performance. So yeah, it's the same kind of thing we're talking about with dialects. You will see the performance of those systems converging over time. It's a question of how long will it take to converge, I suppose.
Right. At some point you reach diminishing returns, or even if there is a theoretical edge to that.
Precisely.
The results are so similar that
yeah, exactly. And like thinking quite idealistically, I'd like to be able to make a system that it just performs well, full stop. It doesn't, have to depend on the speaker or the amount of vocab potential. So we really specialize in large vocab stuff. I'd like that to be just as accurate as the low vocab stuff. It's just something you shouldn't really want to be thinking about. Ideally, as an end user, you don't want to be thinking about that. You just want the system to work.
Yep.
So yeah, that's where we want to get to.
Certainly, from our point of view, anything we need to curate and steer, there's an overhead to that. And if we can curate and steer and add things and get better results, it might be worth doing it. Although there's always a trade-off there. So the less that's necessary, the easier and cheaper and better it's going to be for us to produce captions.
Yeah, makes sense.
We got some more questions. So we had how can ASR adapt models for deviant speech with limited data? Now, we think deviant speech in this context means people with speech impediments or who've had strokes, things like that, and that's affected their ability to speak clearly. So I think that's quite interesting from an accessibility point of view. Actually, something that is, if there is a technology that is able to help people who have trouble speaking speak more clearly, that's clearly something that can bring a lot of value to the world. How easy do you think it would be to adapt current ASR methods to help with a scenario like that?
I think it's hard. It's probably a couple of PhDs in it. I think the domain adaptation approach is probably the way to go. If you've got some unlabeled, maybe even labeled data, so you're only ever going to have a small amount of data. People speaking with particular kind of slurs or from the particular problem they have or whatever, you're only ever going to get a small sample set. So you have to come up with some clever way of mapping that into the domain where you're modeling. So I think it's a question of how well we can start doing that. And I think that would take a concerted effort. It's not, it's really not the kind of, I know lots of people do this kind of thing, but it's not a bread and butter thing for us as a company. Yeah, I mean, I think the hope would be that you could sort of generalize to other deviant speech, as it's put. Hopefully, if you've managed to crack it on a few, hopefully the patterns that exist in those few will generalize to many. And in that way, hopefully you could start attacking the problem. But yeah, I think it's similar to like children's speech. Often that will throw our system. They'll throw many systems.
Yeah, we see that.
Yeah,
for children's programs.
So yeah, once again, there is a question of data, but yeah, it falls into this whole umbrella of just making the system more robust to noise and differences and being able to just deal with it. And yeah, that's something we want to be able to increasingly do.
Questions?
Is there a difference in quality? Oh yeah, sorry. How can I use transcription as a service or as a component with an API? So okay, well that's reasonably straightforward. So you can just go to speechmatics.com and look at the developer docs, and you can integrate. We have an API. Yeah, try us out. You'll get free credits. Make the most of them. See if we're good for your use case. That's the best thing to do. Is there any difference in quality with the actual audio file being processed, i.e. FLAC, WAV, MP3? I don't believe so. I think you'll probably get exactly the same performance, unless you've had some real experience.
We've looked at it because depending on where in our workflow you take the audio, it may be more or less compressed, and we haven't seen huge impacts there. We haven't seen. I mean, we haven't gone that in depth because we haven't seen anything in the initial look that suggested there was huge gains to be had. It seems to be any sensible, professional, modern compression approach is going to maintain the audio features that are required. I assume when MP3, say, is submitted to your engine, it is extracted to be run through the engine into a standard audio format.
Yeah, so it's run through as a WAV, and we have 16 kilohertz and 8 kilohertz models. So depending on which one of those, it'll run through a different model.
So we would never use 8 kilohertz. So I mean, I couldn't comment from our side whether that has any impact. Everything we do would be 16.
Yeah,
sure.
Yeah, I mean, people will see a difference if they have really sort of terrible telephony data going through the 8 kilohertz model. Okay. What is the amount of data, audio text that you need to create the models to a new language? I'm slightly out of the loop on this, but I suspect on the order of thousands of hours of audio and hundreds of millions of words of text. I think nowadays that's a fairly sort of reasonable minimum to go for, unless have you got something?
No, I mean, we talked before about the approach you've taken in some languages where there is less data, where you kind of prime the models or whatever. Do you have a sense of this difference in scale of data required when you take that approach?
Oh yeah, you definitely need less. I mean, you can get away with it because you don't need to learn from scratch all these sorts of low-level acoustic features. We've already learned them on the English model, so it's using. So that does reduce the requirement. Though I think what I said still stands, that it's on the order of thousands for the hours of audio. And of course, yeah, the text situation isn't affected by that.
Okay.
Let's have a look at this next question. What is your projection regarding ASR precision development? What is the period in which ASR precision doubles? If you have 90% precision, how long time will it take to improve to 95% in the same conditions? 1 year, 2 years, 10 years? Well, we are constantly trying to improve our accuracy. Do you have some words to say about this? You have some experiences with?
I mean, we are constantly measuring accuracy, and we see consistent improvements. We're kind of putting together some data where we'd like to be able to put some numbers to that. I can't off the top of my head do that right now, but when you're predicting into the future, it's always hard for us to see, and you probably have a slightly different take on it, or maybe more optimistic. It's hard to see whether there's another leveling off point in front of us or not. Generally, you're quite optimistic there isn't. I have no grounds on which to make an assumption either way or not. I think what was to get from 90 to 95%? It feels like a 3 to 5 year thing to me.
Probably something like that.
Don't hold me to it.
Yeah, I mean, I think so. Once you're talking, so I presume you're talking about word error rates. So that's typically how we measure speech systems, and we'd typically be wanting it to go down by 15% relative. So not absolute, but relative each year at least. Like that would be great if we could do that. And we like to sort of think big and try and shoot for that kind of thing.
Of course, if that holds, as the gap gets smaller, the improvements also get smaller.
Yeah, precisely, and that's just what you'd expect. Like it is diminishing returns once it starts to get so good. And I think we're kind of starting to get into that realm for English a bit, where there are diminishing returns, but for other languages, there are still huge gains to be had. Yeah. We have some other questions. Okay, so the last one that's come in.
That's done.
Oh, that's done.
Yeah.
Great. Okay, we had some others that came in earlier.
One was, how is technology and actual software approaching and evolving in automated translation gaps like slang and humor? And I think this is about the fact that there are turns of phrase that, I mean, certainly in translation are quite difficult to take from one language to another, but there's also linguistic games, puns, things like that, where an ASR engine, as much as a translation engine, is going to struggle because the ASR engine's always looking for the most probable solution, and the most probable solution is not the pun, it's the thing the pun makes a joke of. So yeah, I guess you need some sort of almost human level understanding to start disambiguating these edge cases of humor and surreality.
Yeah, yeah. Or you need your acoustic model to be perfect, and then you don't care about the grammar being weird in that sentence. So we're talking about the case where you might change the sound of a word just slightly for the joke. Actually, if your acoustic model is perfect, it is going to predict the right word. So over time, I think it's going to get better on humor, surprisingly.
But there are some cases where acoustically the word is identical.
Okay, yeah. In which case, you would need that human level understanding to get the joke in the right format, which is probably never going to. Well, now you're talking like 10 years.
If that happens, that's going to be the least of our worries.
Yeah, for sure. The robots will already be taking over. We have. Yeah, so here's a question. Speechmatics, are you able to share your current word error rate? I think the short answer to that is probably no. And although the real answer is to test it on your own data and see what you get, because the kinds of test sets that we test on internally might not match what you have. So the real answer is to test it yourself and see what you get.
So a word error rate can only exist for something. It can't. There's no such thing as an objective word error rate.
Precisely.
We have a big test set of media which we use to evaluate engines and to see what improvements we're seeing. And an update to the engine may improve us in some areas, may make other areas worse because there's a new bias in the data. You can really only talk about it in terms of a specific thing, and that thing may be a specific library of data and not just one file, but it's always a measurement of a thing.
Yeah, precisely. What's the average latency in seconds between a word being spoken and the word being transcribed?
It's configurable.
Yeah.
Yeah. I mean, you can set it to force something out in 1 second. With a hit on accuracy, you can set it to take more time, and as we discussed, that will push the accuracy up, but you get more latency. So it's very much in your gift as you configure it. So you need to decide which is more important to you, latency or accuracy. And actually, the gap you see in accuracy, the difference in accuracy isn't always that high. So it might be you're happy to push it more towards latency, especially if you go to 0 seconds, maybe there's more. But at 1 to 2 seconds to 3 to 4 seconds, there's not always a massive uptick in accuracy testing we've seen.
Is Welsh on the roadmap for support? I have no idea. Try the global model, see if that works for you. If it doesn't, send us a go.
We do subtitling in Welsh, and so it's certainly something that would be interesting to us.
How does the global model do on it?
I don't think we've done it using Speechmatics, and in fact we can't do it with real time. I'm trying to remember how we do it. I think what we actually do is so we do English language subtitles for Welsh programs.
Okay. Even though subtitles aren't often verbatim transcripts, can historic subtitles be used as training data for new languages? If they match the audio, then yes, but if they don't, then no. My instinct on that.
Yeah, I mean, where we've talked to speech providers about this, it tends to be a case of having to align it. So, I mean, generally, there'll be sections of matching speech and text, and there'll be sections where there was some editing. So if you go through and you align it with a high degree of confidence, you can just use the chunks that have aligned correctly in the bits that were edited out. You just don't include that in your training.
what level accuracy is good enough? 95%. Use the man for this.
So it depends on the metric. It depends on the use case. When we show people the real-time solution getting 95% on the NER score, people tend to say, "Wow, that's good and that's usable. That's, you know, as a user of a accessibility service, that is worth using." I think where it's more like 90, it's more frustrating, the errors you're seeing. So I would say around 95% on NER is just about where it starts being like, okay, this is good enough to get the meaning and be comfortable with.
And interestingly, I think if you invert that accuracy score to error rate and say what word error rate is good, it's a different metric. But what word error rate would you say is good enough? Like in my experience looking at English, if it's under 5%, it's pretty much perfect. So that would be my sort of gut feel on that. And then in that range between 0 and 5% word error rate, it's kind of like the errors that you're making are often just errors in the reference transcript, or you've spelt 24 differently or something like this. So it starts to be less meaningful when you've actually got to that 5% mark anyway. That's my completely subjective feel on that one. There's a great gap in performance for reverberated speech, especially for audio registered one microphone. Multi-condition doesn't work very well. Do you think that future ASR systems will be enough robust to treat that kind of audio files? This is one of the data augmentation things that I know that we do. We think about reverberation, we insert it, we try and make our models robust to it. If they're not robust, we need to try a bit harder. We know it's a problem, we're attacking it. After the text AV event and the idea of a common benchmarking tool, how far is the collaboration effort going? Great question. Yeah, we're progressing on it, and yeah, we want to make something open source so that everyone can evaluate us in the same way to other providers. I think that's really important, and we are making progress on it. So it's not a dead project. Pietro, you'll be glad to hear. Is that us? I think we're at 4 o'clock, so we'll wrap up here. Thanks so much for joining us, and awesome, thanks, great. Yeah, thanks for joining us. It's been fun.
Thank you everyone for listening.
Yeah, thank you very much.
Cheers.